we don't really sit down to say, okay, how is this JavaScript actually calling the page? How is it displaying these things? So my interest is in those areas. That's why I love operating systems. I love programming languages. I love databases and things that are low level. So for this talk, I wanted to share a technology with all of you that I'm sure most of you or some of you have heard of and some haven't heard of. It is relatively new, but it may not be that new. So I think all of you have heard of HTML, CSS, and JavaScript as the standard ways of building programs for the browser or for the web. So you write your HTML document, which is the structure of the page that you're writing. Then you add style using CSS to make it more beautiful. And then if you want to make it interactive, you add JavaScript. That has been the standard for many years. Well, as of I think 2015 or so, there was a new standard which was introduced, WebAssembly. And many people who are, let's say, developers, don't really know it or don't find reason to know it. Or they haven't interacted with it. Okay, maybe you have interacted with it, but you don't know that you have interacted with WebAssembly. So in this talk, I would just like to share what WebAssembly is. It's the agenda for the talk. I want us to talk about what is WebAssembly, to understand what it is, to see the history of WebAssembly, how did it come up, what were the reasons for its development in the first place, the applications of WebAssembly, where does WebAssembly fit in the whole entire ecosystem of software development? Is it something that is solving a problem, or is it just a new technology that is being added on to us? Then how do you write WebAssembly programs? That is also something that you can look at. How do you run it, and what is the feature of WebAssembly? So because I think the talk is supposed to end at 5, we are going to go a little bit fast. There won't be demos. It is mostly an informational talk. So you will just be receiving information, maybe up to some certain points. You're not going to be as very experimental as the previous speaker who ran a poll model here. All right, so let us start with what is WebAssembly? Maybe for those who have an idea. By the way, I did mention I am a teacher. Not a teacher per se, but I'm a facilitator. So my technique is usually how I do in class. So I usually just say, what is this? And I ask people around. Give me what you think, give me what you think. So anyone who has an idea about what WebAssembly is, just maybe if you have an idea, just what you know about it.
Oh, I see.
Yeah, yes.
Thank you. This is the assembly code. Machine is perfect. But this time around, I'm going to try machine.
Just like you. How many of you know assembly? Have you heard of assembly before? Yes, we have all heard of assembly. You know how the programs work. You write your program in Python, but your system, your machine doesn't understand the Python. So there has to be series of translations from the high-level language that you speak, which contains the English, the low-level language that the machine speaks. And there is a compilation, interpretation, whatever language it is in it might have various steps, up to the step of assembly, which is close to what the language, close to the language that the computer speaks. That is an assembly language. And every program, at least at some point, runs on assembly. Now, this is a web version of that. So it's a web version of a low-level bytecode. Okay, we're not going to use those big ones. So when they ask Google, what is WebAssembly? This is what comes up. WebAssembly, or Wasm, is a binary instruction format for a stack-based virtual machine designed as a portable compilation target for programming languages. It allows code written in C++, Rust, Go, whatever, to run in web browsers at near native speeds. It is not designed to replace JavaScript. We are not causing war in the JavaScript world, but it is rather to complement JavaScript or in certain tasks that JavaScript doesn't do well, especially when it comes to computation. Well, you have had all those big ones: compilation target, what. But what do they actually mean? So when I say it's a WebAssembly is a compiler target of programming language, it means that when I write my code in C, it's a high-level language. Not just think about the translation process. The machine doesn't understand that high C ink what doesn't understand that. So it has to be translated into a language that the machine understands. That is a compiler's work. But now the target is this language that we're targeting. Most times those languages target either Intel assembly, or they target AMD assembly, which is x86, or they can target ARM if you are running let's say this M chip or Android, whatever. They target those, what we're calling them, instruction sets. RISC-V, but they can target all those various machines, CPUs that are on your machines. Well, now this WebAssembly creates a virtual machine, sort of like an abstract idea of a machine that is not concretely implemented like this, because this is an implementation of a machine. This laptop, your phones, this SC, all those are physical implementations of a machine. Now we can have a virtual implementation of a machine, which can be executed in a software form, and it can be a target for a higher level language to run on. So this is what WebAssembly is. So when C++, Rust, what compile, and even Go, when they compile, they don't need to compile to x86 or ARM or whatever. They can compile to WebAssembly. That is why we're calling it a compiler target. It is fast and secure. So by design, WebAssembly is designed to, like, when we're reading about what WebAssembly was, we said it is running at near native speeds, meaning it's running as fast as something that is compiled for a device. It is written or developed to be fast, and also developed to be a secure runtime. Especially right now that the world is focusing on security, because AI is creating a lot of code which is messed up, and we're deploying it out there. We're now transforming our minds to look at secure ways of building software. One of the secure ways of building something is by isolating it, by making sure it does not interact with the external world, does not interact with the external code. That is how browsers work. Browsers have JavaScript. JavaScript is a, how do you call it, Turing complete language. It means it can do anything. But they make sure that they limit the power of JavaScript by putting it in a sandbox, where JavaScript does not just jump into your file system, does not jump into your logs, it is contained in the sandbox. So if it wants to access a file, it requests. That's where the pop-up comes up and then allow. So same design. WebAssembly is designed from the ground up to be secure, isolated. It does not access a file system. It wasn't designed with it. It does not access a network that wasn't designed with it. It doesn't access any resources like I/O, hardware, software. It doesn't access it. So it is isolated and secure by design. And that makes it a lightweight container. It makes it a small runtime environment where you can run your application code secured. And when I mention container, I think one thing should come into your mind, which is Docker. A lot of you who are doing cloud and hosting them the back end, you have to package up your Docker thing and then, send it to the cloud server to run. However, that whatever you're packaging, because you're copying, you're making copies of various things on your machine to run on the back end, so you end up having a Docker file that is quite huge. Well, we can also talk about the history, how cloud has evolved from those physical ways of doing things up to containers, but that is another thing of its own. So WebAssembly gives us a lightweight version where you don't have to put a lot of things. You just compile the application and it send it. So it is a lightweight container and it's currently being experimented on for, not even experimenting, some companies are using it in production cloud right now. So this is probably an image of how it will look like. You write your Rust code, your C++, or whatever, and then it compiles to WebAssembly, which runs in the browser with the JavaScript, CSS, and HTML. And once you write your WebAssembly code, it can execute at higher speeds, especially so if you're writing your depends on what kind of applications you developers build, but it is specifically for people for projects that are quite complex in their development. All right, so the history of WebAssembly. I personally got to learn about WebAssembly about 4 years ago, and the idea was just still floating around. It was still WebAssembly 1, and well, it wasn't, people weren't talking about it. It was just something that was still in there. But if you are to ask the internet what the history of WebAssembly is, they'll tell you it was announced in 2015 as a collaborative effort to bring near-native performance to browsers. Previously, before WebAssembly was there were projects like native client from JavaScript and Wasm.js from Mozilla. The purpose why these projects were created is because JavaScript is not as fast as we think it is. I know this, yeah, this is going to create more, but JavaScript not as fast as it is. The reason is why it's an interpreted language, and even though we have JIT compilers and all that, they don't bring the efficiency of certain applications, especially, for example, applications like satellite imagery. If you're bringing something like machine learning into the browser, we cannot rely on JavaScript entirely for that because it is not as performant. It's not highly performant for such compute-intensive tasks. So the reason that's why WebAssembly was developed was to be a successor to some of these technologies which were developed individually by different browsers. Because Chrome was developing this idea on its own, and also Mozilla was developing this idea on its own. So there was a joint research that came up to build a joint way of building, bringing native state to the browser. And that is as per the history, because I don't want to bore you with what the whole thing was. But where is WebAssembly applied? Where do we use WebAssembly as a developer? How do you use it? So, again, a simple Google search will tell you all the various places that WebAssembly can be applied. Previously, before WebAssembly was a thing, there are some applications you couldn't find on the browser. But currently, you can use Photoshop in the browser. You can use Flutter in the browser. You can use Figma in the browser. You can use Jonathan was showing me Audacity. Audacity is a audio editing tool. You can now use it in the browser. You can play AAA games, the people who like Call of Duty, who like whatever. You can play them now in the browser because they are taking the advantage of WebAssembly being a fast tool, a fast way of doing things compared to Java. So, like I said, Figma, AutoCAD, browser-based gaming, video processing, machine learning, server-side rendering, all the people who are doing cryptocurrency, all these, any area that you feel like you're building and it's relying a lot on computation, that is an area that you can use WebAssembly. Now, don't think of applying WebAssembly when you're building a static site, or you're building social media, or you're building, there's some places that are not applications of WebAssembly, so it doesn't really fit in that design perspective. So only when you are building something that is like a game, something that is computationally heavy, as you can think that let me transfer some of my computation to WebAssembly. This is just a screenshot from the previous speaker's slide, where he was showing exactly how he was applying WebAssembly in the machine learning task. So you can see, I can't highlight here, but you can see on 917, where he's calling the Onyx, I call it Onyx, which is, I think, a runtime for, forgetting what it is. And it was a research from Facebook. But it's like a neural network runtime thing. And they're setting up the WebAssembly thing, and they're setting up all the threads, and they're running computation on that. That is a realistic application of WebAssembly in the browser, because you can do your face recognition, you can do your motion detection, you can do your object whatever in the browser with such techniques. So how do you write WebAssembly code? So as an average developer, you may not entirely write it by hand. Just like right now, you don't write assembly code by hand. So if you are a framework developer, if you are here and you're building libraries or you're designing programming languages, then you are the one who needs to know the underlying things that are making up WebAssembly so that you can generate a framework for your users to interact on the high level, but interact with the low level WebAssembly. So as an average developer who is just building an application, there's no chance that you're going to interact directly with assembly. You will interact with assembly on a higher level using your programming language. So, but how would you write, if you were to write a WebAssembly program, how would you write it? So just like you realize JavaScript has a bunch of has a structure. Let's say it has variables, it has functions, it has statements, it has all this. So WebAssembly in itself also has a structure. It has types, just like JavaScript also has types. It has integer, floats, strings, and all that, and objects. So also WebAssembly has types, but only has two types. It has integer and float. Then the others are just memory, because everything can be presented as a number. So that's why I mainly has that. So other things build on top of that. It has functions. It has a way you can declare functions. It has linear memory. Linear memory is what we call an array in C or a list languages. But this is a physical linear memory. So you allocate a block 1 to 9 or 1 to 10. These high level languages, they can lie to you that they've allocated a linear block, but actually the memory is segmented into different places. So this is an actual linear memory. So it has also tables. Tables are, that's how you would call dictionaries in Python or objects in JavaScript. It has globals and how to import and export your interfaces to the outside world. Well, that is as of the structure of a program. So liken that to how variables and things are. Then it has a computation model. So you as a developer don't really interact with certain instructions. Yeah, I'm going to call them instructions. So in this case, how we call them, what we call instructions are let's say things like adding. Is if I say a plus b, so the plus is an instruction, which is an add instruction. If I say a minus b, the minus is an instruction, which is a subtraction. So the only way we interact with instructions is using operators on a higher level. We don't interact with them on a lower level, how they are implemented as instruction. So that is one of the things that we have in the machine, in the WebAssembly model. And then the file formats, there are two file formats. There is Wasm, which is the compiled version, and then there is WAT, which is the text version if you want to write. So like that's like how you can write assembly in a human way, like Intel assembly in a human way, and it is generated into the binary form, which is the .exe or something like that. Same thing, we can write our text in .wat, which is the human way of doing things, and it is compiled into the .wasm, which is the binary way, the binary format that you cannot read, but the machine can. This is a simple example of an addition function in WebAssembly. So this function is called add. Okay, So before we get, this is a valid program. It's a valid WebAssembly program. And what it does, it's creating a module. So let me remember we talk about structures anyway. So it's creating a module, and this module we are declaring that we are exporting an interface of add. So that is how we are using that keyword export to export an interface. And then we are saying that we are creating a function called add and takes in two parameters and returns this result. So the two parameters, as you can see them, the one parameter is x and the parameter is y, and they are of type i32 and i32, which is integer of 32 bits and 32 bits, and they return a result of 32 bits, just like that. And then now, instead of doing something like, let's say, x plus y, remember we said this is a stack-based thing, and I don't know how to. Okay, I think I know how to, but it will take a long time to explain what a stack-based machine is. But basically, a stack-based machine, when I say x plus y, in order for the class to access these symbols, the runtime first places x on a stack and then y on a stack. So the add comes and then pulls out the items on the stack and then adds them and then puts the result on the stack. That is a form of computation. But I don't really talk about that. So what this one does is that it gets a local variable x, local variable y, and it adds them together using the i32 add instructions. And then that is how we get our result. So this is the simplest program you are going to see written in WebAssembly. I'm trying to explain, but so it's the text format. It uses what they call S notation. That's why you're seeing a lot of brackets here and there. So it's a different format, different from how you write your high level code. But after writing it like that, how do I run it? Well, first you have to compile it. And there are many ways you can compile it. I just haven't written how you can compile it, but it has to be compiled to WebAssembly first. And then there are various ways that you can run it after it has been compiled. So you need like a WebAssembly compiler. Most times, like I say, you as an average developer, you won't need to interact with the tools yourself. You won't need to interact with the assembler yourself. So if you're writing the code in Rust, writing the code in Python, all the compilation is done for you. You don't have to worry about it. But if you're a framework developer who wants to know how these things are compiled, then you have to go deep to learn the tools involved. And these are open source tools, basically developed by the foundation itself, which is working on WebAssembly. So, but how do I run my code? So if you've written your Rust, if you've written your C++ and all that, and you have compiled it, you have written the compilation targets to be WebAssembly. Currently speaking, like I mentioned, it is a standard, but it is not yet given a tag in the browser. So the browser cannot load WebAssembly directly for you. Basically for a security reason, but also because it hasn't yet evolved to that stage yet. Just like how you can leak a script or you can leak CSS in your HTML, you can't leak WebAssembly direct. The only way to interact with WebAssembly right now is using the JavaScript API in the browser. So that is an example point. I'm not a JavaScript expert because I think this looks weird. It looks weird to have such syntax, but this is how you run the WebAssembly in a browser. So you rely on the WebAssembly API, which is uniform on all browsers, be it Firefox, Chrome, Safari, Edge, and any other browser which is commercial out there and implements WebAssembly. This is a documented API that you can use. So you can instantiate while fetching, which is you get your JavaScript as a stream, just like the way you load a video or load something. That is the same way you load this WebAssembly. Once you load it, you can execute it using an exec. Yeah, like I say, JavaScript. Then that's how they do their things. We won't argue with them. That is how they do their things. But maybe you can decide because WebAssembly has found a lot of use cases outside of browsers. Browsers was the initial way of doing things, but right now, because of the power of WebAssembly, a lot of work and use cases are outside WebAssembly, where WebAssembly containers are being built, secure runtimes, TEE, those ones that are running. So every phone, I think every modern phone has it. An isolated chip called the TEE, which is I think it is a secure execution, something like that, which is isolated from the normal. That is where if you're using transactions like bank transactions, all that secure information is kept separate from the phone memory, and it's kept in that TEE environment. And nowadays, TEE is being built around WebAssembly, the architecture. So, like I said, unless you are willing to go into the deeper engineering of that, and that is where if you're a developer, you cannot be replaced by AI. You'll be replaced, but AI is going to come for you up here in the surface name, because you're competing with AI that can do multiple things. But if you come down to the engineering of these low level technologies, you won't be easily replaced, because these are the things that are powering AI up there in the first place. So the secure environments are built using such technologies. So there are standalone runtimes like Wasm Time, Wasma, V8 is also a run code. V8 for this would be JavaScript. It's a Chromium runtime. So there are lots of external standalone tools that you can use to execute Wasm WebAssembly programs. So, for example, like for Wasm time, you can just call Wasm time with the compiled version of this, and it will run. So it can be anything. It can be a lazy player. It can be a game. It can be what, and to be able to execute it in a WebAssembly container. So, and the other way that maybe not talk about that much is you embedding WebAssembly in your application. I know most of us don't build big applications, but there are some applications that embed programming languages inside them. For example, I don't know how good you are with the Office suite, but Microsoft Word has JavaScript inside it, so you can write extensions with JavaScript. And Excel has VB script, the one that executes those those how do you call them, functions, the VLOOKUP, all that. That's an execution environment inside there. So there are big applications which can embed languages in there to make the whole experience interactive. So if you're building such a big application, for example, I am currently almost thinking about building a big application. I don't want to commit, because when I commit, people always come and bash me. But yeah, I have an idea of building a big sort of application. Who knows Odoo? I think many of you know Odoo, so free advertisement. Odoo is like an all-in-one enterprise place where you can get your enterprise software. So you just get your application, but this whole application comes with small modules. So it's an ERP. So it can come with your POS, it can come with your inventory management, what. All of them are standalone things. And even an external developer can build a module. But how they build a module is through Python and then the extension. So internally, Python runs those extension modules. However, I realized one time that there is a bug in there. I published about it. Kind of people talked about it, but the thing is that they won't patch it because the bug is actually in the open source version of it. It's because the way they run their Python scripts is very unsafe. Like I said, Python is a theory complete language, so it can access anything on your hardware. So when they execute the Python code, the Python can take control of the network, can take control of without Odoo's permission, because it does not take initiative to secure that. The only secure version is the Odoo Online, the Odoo Enterprise. So one of the things I wanted to do is to patch this using WebAssembly to create containers, but then that is too much more. So, but that is one way that you can think about securing, let's say, or do to run external code. Yeah, that is remote execution. Even when you are hacked, by the way, imagine your whole entire browser, your whole entire workstations is running inside WebAssembly. So if you access a browser while you're inside WebAssembly and you access some malicious code, the malicious code will execute and have affect the browser. But since the browser is inside a WebAssembly container, it will still not access your entire operating system. So whatever will be affected will be in the enclosure of WebAssembly. So it is because of that sandbox technology that one of it's important and being researched in container and cloud service environments. So those are some of the tools, runtimes that are used in the cloud. And basically, that is my whole entire talk. I hope from when we began to right now, you know what WebAssembly is, you know what it looks like, you know what it is used for and what it is not used for, and you can go dive in deeper. If you're an engineer, if you want to do the lower level stuff, you can dive in deeper. But if you are okay with the surface stuff, this is a lot of information for you to just know that it exists and that your language, perhaps your language of choice, supports it. And if it doesn't support it, you can probably contribute to add support of WebAssembly in your tools. So other than that, that is the end of my discussion. Is there any questions?